Hello, my name is Jim Olson, and this is a video on substitution and elimination. These are going to be used to solve systems of equations. I'm making this video for my Math 100 students, but I'm making it available also for the general public. Let's take a look at our handout. In this video, I'm going to show how to do substitution, how to do elimination. We're going to be looking at graphs, and then we're going to look at the odd cases where there are no solutions or an infinite number of solutions. A system of equations, and this is plural equations, means that there's going to be more than one equation in more than one variable. So let's take a look at some examples from our book, what the questions are going to look like. Here are some examples. For example, in question 1, we have the equation y equals x minus 5, and the second equation is x plus y equals 9. Two equations with two letters. Let's do the example on our handout today. And I'm going to be using substitution. Here's example 1. Solve the system by substitution. Y equals 2x plus 3 and y equals negative 1x plus 6. Y is equal to this package, y is equal to this package. So I think what I'm going to do is substitute into the first equation. You can substitute into either one, you'll get the same thing. I'm going to take this package and I'm going to put it in for y in the first equation. That will give me negative 1x plus 6 equals 2x plus 3. Notice that I have only one variable now, so I need to solve for x. I'm going to add 1x to both sides of the equation, which will bring the x's to the right-hand side of the equal sign. And I'm going to subtract 3, and I'm going to have my constants on the left-hand side. On the right-hand side, I have 3x plus 0, which is 3x. And over here, we have 6 minus 3, which is 3. Then I just have one more step of algebra, divide both sides by 3, and I get x equals 1. The answer to my system is going to be an ordered pair. I need to have an x value and a y value. So I'm partway done. I know that x equals 1. Now, in order to find the y value, I'm going to take one of my equations. It doesn't really matter which one. Maybe I'll use this second one, together with this fact that I know that x equals 1, and find y. So I'm going to be substituting 1 in for x. I get y equals negative 1 times positive 1 plus 6. That's negative 1 plus 6. Y equals 5. So you can write the answer two ways. You can write it as an ordered pair. And when I say ordered pair, I do mean ordered pair, order matters. You can write it this way. Or if you'd like to say that x equals 1 and y equals 5, I will also accept that. This ordered pair 1, 5 makes this equation true. And it makes this equation true. Now let's do one from the book. Let's do question 11. Solve by substitution, verify your solution graphically, or by checking that it satisfies both equations of the system. Let's write number 11 down in your notes. Pause the video if necessary. Okay, we're going to do question 11 by substitution. And this is set up nicely for substitution because y is equal to this entire package. This entire package is going to be substituting in for y. And the rest of the equation, the second equation, is going to stay the same. So I'm going to have 2 times the quantity 0.2x plus 0.6. That's into the y position, and the rest of the equation stays the same. Now I have to do the distributive property, 2 times this term plus 2 times this term. 0.4x plus 1.2 minus 3x equals -4. And I'm going to proceed with my algebra. These are like terms and they are on the same side of the equal sign. So I'm going to combine like terms. That's going to be -2.6x plus 1.2 equals -4. Now I'm going to subtract 1.2 from both sides. It's not a like term with this. Subtract 1.2, -2.6x equals -5.2. And I have one step of algebra left. I'm going to divide by -2.6 on both sides of the equal sign. And 52 divided by 26 is 2. A negative divided by a negative is positive. So I have x equals 2. And now I'm going to be substituting that back in to the first equation to find y. Y is equal to 0.2 times 2 plus 0.6. 2 times 0.2 is 0.4. 0.4 plus 0.6 is 1. So I have the ordered pair 2, 1. Make sure that you put x in the first position and y in the second position. Now I'd like to do the check 2 ways. The first way I'm going to check it is with Desmos. So let's jump over to Desmos. So here's my first equation. Y equals 0.2x plus 0.6. Okay, it looks good. It has a small slope of 0.2 and it has a y-intercept of 0.6. And here's the second equation. It's the blue line. All the points on this red line make the first equation true. All the points here on the blue line, there's an infinite number of points on the blue line that make it true. But this point right here, this point right here is going to make both equations true. 2, 1. So I have used a graphing calculator to check this. Now let me show you how to check it algebraically. It's supposed to make these two equations true. So I'm going to put 2, 1 in for x and y here. 1 should be equal to 0.2 times 2, x is 2, plus 0.6. I like to use a question mark on my check because I'm hoping it's true, but I don't know if it's true. 0.4 plus 0.6, ding, ding, ding. This is true, and I'm happy about that check. Now I'm going to check it in the second equation. This point is supposed to make the second equation true. 2 is going to go into the x position. 1 is going to go into the y position. And I'm hoping that this is equal to -4. Let's see if it's true. This is 2 minus 6. 2 minus 6 is -4. Bada bing, bada boom. That's check. That's true. I'm happy about that check. And here is my answer. So this has been 2 examples of substitution. Now I would like to do some examples of elimination. We're going to begin with number 20. So let's switch over to the book. The directions here are to solve the system by elimination and verify your solution again. Let's write number 20 down in our notes. So for the elimination method, we are going to be eliminating a variable, either x or y. You do want to have the terms lined up, the x terms lined up, the y terms lined up, the equals lined up, and the constants lined up. They don't have to be in this order, but they have to be in the same order. This has good potential for eliminating y. I have found over my many years of teaching that the students usually do better if they add the equations. Always add the equations. If you have success subtracting, you may do that. So I'm simply going to multiply this top equation by -1 on both sides of the equation. And that's going to turn it to a -3y. So I'm going to put it right down underneath here. Using distributive property with -1, I have -2x minus 3y. -2 times -1 is +2. This is going to be set up now with a +3y and a -3y so that they will be eliminating. I draw a line and now I'm adding the equation straight down. This gives me -1x plus 0 equals 4. Maybe I'll put -1 there like that for emphasis. Now I just simply need to divide by -1. I could multiply by -1. I get the same answer. 4 divided by -1, a positive divided by a negative is a -4. Now I'm going to be proceeding as I did on the last example, substituting in to find the other variable. And I think I'll use the first equation. You can use either equation. -4 goes in for x. I don't know y equals -2. I'm using the original equation. 2 times -4 is -8. Add 8 to both sides. 3y equals 6. Y equals 2. So I have -4, comma 2. And this could be checked by substituting to make sure that the statements are true or by a graphing calculator. Now I would like to do one slightly more sophisticated. I'd like to do number 26, which is also elimination. So let's take a look at the book. Here is number 26. Let's write this down in our notes. -3x minus 5y equals -22 is the first equation. And the second equation on number 26 is 4x minus 7y is equal to -39. This one isn't quite as convenient for eliminating x or y. What I'm going to do here is I'm going to multiply this top equation by 4, which will make this -12x. I'm going to multiply the bottom equation by 3 to make this +12x, and that will cancel these out. It's kind of like a common multiple with one of them negative and one of them positive. So I'm going to be multiplying this top equation by 4. So let's swing that down underneath here. Distributive property, I have -12x minus 20y equals 4 times -22. I can do that by front end. I get -88. Now I'm going to multiply this second equation by +3 and swing it down here. 12x, 3 times -7 is minus 21y, and 3 times -39. Okay, we might need to do that one on a calculator. It's -117. So this is going to eliminate because this is going to give me 0x. So adding the equations now, I get 0 here, -21y and -20y is -41y, and -88 and -117 is -205. Now dividing both sides by -41. A negative divided by a negative is a positive, and I got y equals 5. Now I'm going to substitute that into the first equation to find x. I know what y is. I need to find x. Negative 3x minus 5 times positive 5 is equal to negative 22. Negative 5 times positive 5 is negative 25. I'm going to add positive 25 to both sides. Negative 3x is left on the left. Negative 22 and positive 25 is 3. Divide by negative 3, and I get x equals negative 1. So I'm getting negative 1 for x and 5 for y. Now, let's say that it's an exam and maybe you're short on time and we don't have time to check both of these. Since I used the first equation to get my ordered pair, if you're strapped for time, maybe you should check just in the second equation. So checking in the second equation, substituting x is negative 1, y is 5, I get 4 times negative 1 minus 7 times 5, and I'm wondering if that is equal to negative 39. A positive times a negative is a negative times a positive is a negative. So I have negative 4 minus 35. That is, in fact, negative 39. Bada bing, bada boom. So this checks. Put a box around your answer. Now I'd like to go to kind of the oddball cases. We've done quite a few cases where the system had one solution. Now I'd like to talk about what happens when there's no solutions or an infinite number of solutions. Let's write this example down in our notes. Y equals 2x plus 1 and y equals 2x plus 5. Maybe you can visualize ahead of time and anticipate the next step as to what's going on. In this case, I'm not specifying which method to use, substitution or elimination, so we could use either one. I think I'm going to use substitution. So I'm going to put 2x plus 5 into the y position of the first equation. 2x plus 5 is equal to 2x plus 1. Subtracting 2x from both sides, I get 5 equals 1. Our goal is to make this true, but this is blatantly false. This is always false. X and y cannot affect this. X and y aren't even in that equation. So this has no solutions. Now, let's take a look and see what the graph looks like. And maybe you already know what the graph is going to look like. Let's look at Desmos. Here's my first equation, y equals 2x plus 1. The second equation has the same slope, but a different y-intercept. This one crosses up here at 0, 5. These have the same slope, which means they're going to be parallel. Parallel lines will never intersect. It's impossible to get an ordered pair that makes both of these true. Therefore, there are no solutions. Now, there's one other vocabulary word here. There is no solution when the lines do not intersect. They're parallel. And the system is called inconsistent. And you may need to use that term in your homework. This is inconsistent. Okay, so that's a case where there are no solutions because it is blatantly false. Now let's see what might happen to give something blatantly true. Let's write down this next example. Y equals 2x plus 1, and 6x minus 3y is equal to negative 3. This is my next example. And I'm going to use substitution again. I'm going to be substituting 2x plus 1 into the y position. The rest of the second equation will stay as is. So I'm taking y out of the volleyball game and I'm putting in 2x plus 1. It's a quantity. Now I need to use the distributive property with negative 3. Negative 3 times 2x is negative 6x, and negative 3 times 1 is negative 3. These are like terms on the same side of the equal sign. That's 0. 0 minus 3 is negative 3. I get negative 3 equals negative 3. This is blatantly true. This cannot be made false because x and y don't even affect this. This one is always true. So this one is going to have an infinite number of solutions. Let's take a look and see what this looks like on Desmos. So here's the first equation, y equals 2x plus 1, and the second equation is 6x minus 3y is equal to negative 3. And let's make that a different color. Let's maybe make this kind of gold. And also let's make it dotted so that we can see both of them. Ah, very nice. Yes. The purple line and the orangish goldish line are the same exact line. Every single point on here is making both equations true. We get an infinite number of ordered pairs. So my solution is the entire line, and you can write either equation. I think I'll write the first equation, y equals 2x plus 1. So that's the solution set. It's the entire line. This is an infinite number of solutions, and this one is called dependent. An infinite number of solutions occurs when it's the same line, and this is called a dependent system. Dependent. This has been a video on the substitution and elimination methods for solving systems of equations. Have a great day.